want to learn from these courses to have a structured presentation or follow a flow of ideas during my presentation. I want to focus more on the things that I know about my slides and don't try to pay attention or try to explain things that I'm not really sure about. And I want to stay focused and calm when I'm giving the presentation to her. Okay, and for this presentation I'm going to talk about a case study comparing a traditional and innovative broiler system in the Netherlands. And the content of this presentation has an introduction, a sensitive and trade-off analysis, the results of this analysis, and some small conclusions, and a round of questions if there's time and people have questions for me. Okay, I'm going to start talking a little bit about the broiler industry in the Netherlands. Currently, the Netherlands is 230% self-sufficient in broiler meat, which means that the broiler meat is a very high consumed product in the Netherlands. I'm pretty sure that almost all of us eat regularly chicken. And also because of these figures makes it a very highly exported product within the European Union countries and also other countries outside the European Union. This brings some problems, especially in environmental and social aspects, which I'm going to speak a little bit more in detail in the next slides. For the case study, we are comparing two systems, a traditional one and an innovative one. Some of the features of these systems are compared and varied to see how well they perform under certain conditions. For the traditional system, we have one that has forced ventilation, artificial lighting, fast-growing broilers, a 42 days cycle, only clean once in the production cycle, and it has a heat exchanger to help conserve the heat in the house. For the innovative system, it has a natural ventilation system. It follows a day-light cycle, uses slow-growing broilers of 56 days. It has a regular cleaning because of the natural ventilation of it, and it doesn't have a heat exchanger. And for maintaining the production levels as the ones that I mentioned earlier, it is important to aim for sustainability in the production. And to do so, we have to focus in three aspects: environmental, social, and economic. All of the aspects needs to be evaluated in some way. So for this case, we're using three indicators. For the environmental aspect, we use the indicator of the energy use in kilowatts hours per year. For the social, the indicator is the fine dust concentration. This is how much air pollution is produced by the house, and it's liberated, it goes away from the house into the neighborhood areas. And on the economic aspect, we have the indicator of, or we use the indicator of net farm income and euro. And to evaluate these aspects and its indicators, we develop or we make a sensitivity analysis. This means that certain factors of the aspects were varied, and we saw which ones of them had a bigger impact on the performance of the system. For example, in the case of the traditional system, the environmental aspect, we changed the leakage factor. This means the air that goes out from the house, and the insulation roof value. It means the value that can contain the conductivity of heat in the roof. And on the other hand, for the traditional system, innovative system, we vary the insulation and wall and roof values. These two were the most sensitivity for the environmental aspect. For the social one, we varied the lighting and we tested a production dust reduction system. This was called the negative ionization system. And for the economic aspect, the feed conversion and the investment of building and equipment were the most sensitive aspects that we found. Once we have these different elements, we created scenarios when focusing only in one aspect, for example here environmental, social or economic, and then focusing in two aspects, trying to get the most out of these characteristics. And finally we have a scenario where we varied all the aspects together to see how well the system will perform, and we compare to a desired scenario, which in this case is the utopia point in this Pareto graphic, which means that it's the point that you want to get having the lowest energy consumed and the lowest fine dust concentration group as well. And we can see here that the innovative system has a very low fine dust concentration, but has a very high energy consuming. This is because the heat exchanger that is not present in the innovative system, because it doesn't have a heat exchanger, it means that it needs a lot of energy to maintain the heat inside the house. On the other hand, in the traditional system, because it has a heat exchanger, the system saves a lot of energy, but the production of dust is very high because it is contained and it's not cleaning very often, unlike the case of the traditional system. On this analysis, we are comparing the economic and environmental aspects, and we can see that the net fair income is higher in the traditional system. This is mainly because of the shorter cycle of production, only 42 days, compared to the innovative cycle that is 56. But again, the energy consuming is higher in the innovative system because of the heat exchanger again. And lastly, comparing the economic and social aspects, you can see that the innovative systems behave better because it can produce a little bit more and consuming less energy than the traditional system. Again, because of the same things, the heat exchanging and the cleaning, how often it's cleaned, etc. Okay, so finally, analyzing all these results and all these scenarios, we observe that the ones that have a better performance are on the case of the innovative system, is the scenario number 8, which contains we bind all the elements together. It has a more an average of a well performance, or it's better, or performs better. Right? And in the case of the traditional system, as well, the scenario where all the experts were varied together, it has a better performance than all the others that only varied one or two aspects. So in conclusion, I can say that the innovative system has better values for dust emissions, so it focuses more on the social aspect, less pollution to the air, and we saw that the heat exchanger has a large influence on the energy consumption. Generally, the traditional systems can achieve better performance in the economic yield, so you can earn more from the traditional systems, but it lacks the attention of the social aspect. And finally, with this result, we can say that the best trade-off scenario is the number 8 for the innovative system because it has a more average distribution for all three aspects that we are looking for to get. And that's it. Any questions?